Covalent bonding involves the sharing of electrons, and for each shared pair of electrons you'll be forming one covalent bond. And atoms that love to do this are in the middle of the periodic table, and they love to share with the other ones. Of course, never with the ones in group 8, because those are already very happy the way they are and they don't need to barter electrons. So carbon, for instance, has atomic number 6, so we can put 2 electrons in the first shell and we can put the other 4 in the second shell. So carbon is looking for 4 more electrons. And we call them valence electrons because they are in the valence or outermost shell. And another way of saying this is to say that carbon has a valence or a covalence of 4. And another way of saying that is that the bonding capacity is 4. So it has a bonding capacity of 4, which means it is going to be looking to make 4 covalent bonds. Now, each hydrogen has atomic number 1. So each hydrogen will have a single electron in the first shell, and that shell holds only up to 2 electrons. So hydrogen is looking for 1 more. So hydrogen has a valence or covalence of 1. And so if you have 4 of them, each one will be the same, of course. So when 4 hydrogens meet a carbon, first of all, to get rid of carbon could potentially get rid of, think of getting rid of 4 electrons or gaining 4 electrons, but it's not going to be able to find other atoms that will either take the electrons or will give it all of those electrons. That's not possible. It's too many electrons involved. So what will happen instead is a sharing arrangement. And so 4 hydrogens will meet a single carbon, and together they will figure out that they can make each other very happy by sharing these electrons. And what that does is it gives each carbon access in its outer shell to the magic number of 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. So its outer shell is it's double whammy. It's full, and it's also reached the magic number of 8. Each hydrogen is also very happy because it is looking for a total of 2 for a full outer shell, and so it has access to 2 electrons, each of these hydrogens. So everybody ends up stable and happy. And what you've really done is, of course, you've made 4 covalent bonds total. Each is a shared pair of electrons. Now the maximum number of bonds, covalent bonds, between any 2 atoms is 3. So that means carbon can form 1, 2, 3, 4 bonds with 4 other atoms or groups of atoms. Carbon can also do this, so it might bind an atom of element X and an element Y. So notice that this adds up to a total of 1, 2, 3 valence of 4, but no more than 3 in between any 2 atoms. And so maybe carbon could also do this. I'll have to think of another letter. I'm just going to say P, whatever that is. And so now we have 1, 2, 3, 4 total, no more than 3 in between any 2 atoms. And so carbon is very versatile. Notice it can bind with all sorts of things in all sorts of ways, which makes it a great material for life.